Today we are walking through the paper titled Advancing Mathematics Research with AI-Driven Formal Proof Search.
Can we start with the big picture?
The paper asks whether LLM agents can do more than solve polished contest problems. It tests whether they can help with open mathematics research by writing lean proofs that a compiler can check line by line.
So the safety net is the proof checker.
Earlier successes were mostly in Olympiad-style theorem proving or informalizing arguments that humans had already written. Open research problems are rougher. The agent has to search, repair failed proof sketches.
What does this system actually receive as input?
A mathematician gives a lean theorem with the proof body left as sorry, plus optional natural language context and domain libraries. The job is to replace sorry with code that proves the exact theorem. The method is called Alpha Proof Nexus. This architecture is the proposed system, so let us look at it before the result charts.
I see prover and trader subagents. Which pieces matter most?
The prover subagent edits the lean proof and listens to compiler errors. The proof validator checks that the theorem statement was not changed unsafely. The population database stores sketches, gold proofs, and double scores, so future attempts can start from stronger prior sketches. The example run shows why that loop matters. On an Erdos problem, alpha proof resolves several goals. The LLM decomposes the remaining one into smaller lemmas, and the second alpha proof goal finishes the proof.
Is this just one nice demo, or did they evaluate it systematically?
They ran a large evaluation on open problems. The strongest agent resolved 9 out of 353 formalized Erdos problems. On OEIS conjectures, it proved 44 out of 492 after filtering and formalization.
What kind of open problem did it solve?
One highlighted case is an Erdos question about some sets. Let A be the numbers whose base 3 digits are only 0 and 1, and let B be the analogous set in base 4. The question asked whether A plus B has positive lower density.
And what answer did the agent find?
It proved the answer is no, the lower density is 0. The proof used an inductive thinning argument and exploited close numerical alignments between powers of 3 and powers of 4. Now the result chart compares for agent designs by solve rate and mean inference cost across 6 Erdos problem instances.
Which comparison should I focus on first?
First, adding alpha proof to the basic agent usually matches or beats the basic setup at similar cost. Second, throwing more independent attempts at the same problem gives diminishing returns. The curve improves, but each extra batch buys less.
But the red triangle for the sunset problem looks different.
Right, for the hardest highlighted case, the full-featured agent has a much higher solve rate than the basic and alpha proof-only variants. Though it also costs more. That is the main trade-off. Evolutionary search is not always cheapest, but it can unlock problems the simpler loops barely touch. The basic agent is much simpler. It repeatedly lets one LLM session edit a sketch, sends compiler feedback back into the session, and stops if a valid proof appears.
Then what does the full version have beyond that loop?
The full version runs prover and rater agents as in Ruxiancy. Provers can call alpha proof on hard goals. Raters compare previous sketches, update TELO scores, and the controller samples better material for the next attempts.
Did they only test benchmark sets, or was it used with mathematicians too?
They also deployed it in active research areas including combinatorics, optimization, graph theory, algebraic geometry, and quantum optics. One graph theory example proved a conjecture from the graffiti automated conjecturing system about spanning tree leaves and independent sets in neighborhoods.
What is the most important limitation to remember?
The results are impressive, but not magic. The benchmark is limited to problems already formalized in lean. The hardest searches can cost hundreds of dollars per problem. And the system still depends on careful validation to prevent invalid edits.
So what should viewers take away?
The main claim is that formal proof search is becoming a practical research tool. LLM is propose and repair proofs. Lean checks correctness. Alpha proof helps on hard subgoals. And evolutionary reuse makes difficult searches more effective.
That makes the result feel less like a chatbot answer and more like a search engine for verified proof attempts.
Exactly. That wraps up this paper walkthrough.